All right, so good morning. Thank you so much for getting up. I really thought I was going to be talking to myself this morning, so I do appreciate that. For those of you who don't know me, my name is Maria Colgan. I'm part of the product management team for the Oracle database. And today what I'm going to do is give you an idea of where I believe the future database is going. I'll tell you which features and functionality that exist in the Oracle database today that are pushing us in those general directions so that you'll get a sense of what's going on, and depending on which of the directions that interests you, you'll know where you can get started today. So that's what the point of today's session is. Standard safe harbor, please don't hold anything I say against me, because as I said, these are my opinions about where I think the industry is going. Now, this one isn't my opinion, but it's being forced upon all of us, whether we like it or not, and it's the fact that the industry is being pushed or transitioning towards the cloud. How many folks with us today are actually already on the cloud? Let's start with that one. Oh, wow. Okay, so we've got some already on. How many are, it's certainly been discussed at work and we're thinking about it. We don't really know what we're doing, but we're moving in that general direction. Okay, all right. And then for the rest of us lucky sods, we're just staying on premise, right? Fair enough. So regardless of whether you're going to the cloud, and there's a couple of reasons why people are looking at cloud, right? There's a lot of advantages to it, from agility and elasticity and cost really tend to be the things that people are talking about. But regardless of where you are at, you could possibly be here on the left-hand side, most side of the slide, where it's all about the best of breed. You've plugged together your own infrastructure, your own hardware, you've got your own blueprint of the kind of systems that you run the Oracle database on. How many folks are on the far left, that it's a bunch of different things? We have somebody else's server, somebody else's storage, and the Oracle database sitting on it, okay? How many folks are in the middle, where they've moved towards the engineered system, the hardware and software kind of being written together and optimized as one? So there's a couple of folks in that one. And then, as I said, there seem to be a couple of folks that are all the way on the right-hand side. Regardless of where you are, the Oracle database has always evolved to ensure that it has the functionality that you need, regardless of what platform you're going to run it on. So that's the good news. And we've been doing this for 40 years. Oracle turned 40, if you're not aware of it, on June 16th. And the database has evolved and continues to evolve and innovate with new features and functionality. So as I said, as the industry is changing and we're taking different directions, I'm going to show you within the database where we're going with that. In order to make it a little bit more interesting, instead of just throwing random topics out, I thought we'd look at things in under different headings. We'll start with performance, because that's my favorite thing. But we'll move on. We'll look at security, which as we move towards the cloud becomes more and more critical. We'll touch a little bit on developer, but I'm guessing a lot of folks may have been in Chris Saxon's session last night for developers. How many folks were with Chris yesterday afternoon? Yeah, so that'll all just be a quick refresher for you. We won't spend too long there. Then we'll move on to management, availability, big data, and analytics. Now, I normally ask this right at the beginning, and I didn't, but before we get really into it, how many folks would put themselves in the developer job role? Okay, don't panic. We will focus in. How many in the DBA? So about 50-50 split. So I'll try and address each of these new advances or the new features in both how it looks from both sides, so that we've got it covered. So as I said, we're going to start with performance, because it's my favorite thing, and it's 8:30 in the morning, so we've got to do something that gets us out of bed. So what's new and what direction are we going in? Traditionally, databases have offered you data in one format or another, either a row format or a column format, depending on which vendor you go with. I personally believe that the industry is and the future of database lies in dual format databases. The ability to have the same data in both a row and a column format simultaneously. Now, why do I believe that? I believe that we are no longer going to be able to have purely transaction processing systems and then days later have that same data show up in a data warehouse or a data mart and wait to run analytics only when it shows up over there. I actually think we're going to have a lot more mixed workload environments where we are running reports directly on, or analytics directly on transaction processing systems. How many folks are running that kind of system today already, where you're running reports or analytics, some kind of real-time workload on transaction processing systems? Okay, a handful of you. I mean, it can be anything from simply a month-end report that gets run on the transaction processes system that leads you in this direction, but there is a huge push for real-time analytics. Instead of making business decisions on data that's old, that might be hours, days, or weeks old, people want to make it up to the minute data, and that is going to force us to be in this mixed workload environment. What does a dual format do for us in that? Well, for a transaction processing system, the best format for that is a row format. Why? Because all of the information that we need about a record is stored, co-located in that row. So we insert a new record, we insert a new row. We need to update an existing record, we just update one row. If I need to remove a record or delete it, cancel an order, I can simply delete the entire row. So transaction processing, the best format for that is definitely row. But analytics are different. If I'm running reports or I'm running some kind of analytic query where I'm really going to be interested in just one or two columns, but I want to examine all of the data that we have in the table for those columns, a column format is much more efficient. Why? Because it allows me to access only the data that I need for that query, because I only access the columns that are requested. Now, where the wheels may fall off the cart is keeping these two things in sync. If I have data in two formats, how do I keep them both in sync? Well, with Oracle Database in memory, it's super easy. The column format only resides in memory, and it's kept transactionally consistent at all times. So we keep it consistent the same way Oracle has always kept indexes consistent with tables. We're doing the same thing with the in-memory column store. But because we're not persisting it to disk, there's no redo or undo generated for it. So if you're familiar with creating an index, it can actually slow down the workload, even though you've put it in there to speed it up, if the workload does a lot of transactions, because we have to maintain that index. Because the column store is maintained only in memory, the overhead for maintaining it is much, much lower. So it's pretty cheap to do it, which is nice. So because it's not persisted on disk for the DBAs in the room, using this as a performance enhancement doesn't impact your backup and recovery strategies. It doesn't impact any replication you might have going on, because the data is on disk in the traditional row format just as it is today. From a developer's point of view, you might be involved in trying to work out what objects belong in that column store, but from an application coding point of view, nothing changes. So you don't need to know where the data is. Oracle will automatically direct any query that we believe will benefit from the column format directly to it. So you don't need to make any changes. Now, I'm not going to lie to you, the in-memory functionality that I've just mentioned is an option. It's going to cost you dollars. So why would you pay for it? If we could, there's a lot of DRAM in servers right now. We could just stuff it all into the buffer cache and leave it there and not pay Oracle any more money. Now, the buffer cache, remember, the data is in a row format. So why would I pay Oracle money for this in-memory stuff? I gave you one of the reasons already, because for analytic queries, we only want to touch a small number of columns. So by putting data in a columnar format, I can physically reduce the amount of data I have to scan. But there's some other advantages to it as well. How many people are familiar with the concept of a storage index? So a storage index, if you're not familiar with it, for each extent, it records the minimum and maximum value for a column. And when we bring the data into memory, although they are stored as separate columns, they are ineffectively in extents. Now, we call those extents in-memory compression units, but it's effectively an extent. And for each one of them, we record the minimum and maximum value for a column. So we're effectively partitioning that column into chunks, and we can do pruning or data elimination by comparing the value we're looking for with that storage index. If the value we're looking for falls between the min-max range, then we need to scan that extent or that IMCU. If it doesn't fall between the min-max range, then we can skip it altogether and speed up your query performance by just not reading data. So that's the second advantage. The third comes from the fact that we've designed this column format to be able to take advantage of something called SIMD vector processing. How many folks know anything about vector processing? Or a little bit, 2, 3. What it is effectively is, instead of going to each entry in the column one at a time saying, are you the value I'm interested in? We'll take a bunch of values from the column, We put them into the cache on the CPU chip, and we evaluate all of those entries at the same time in a single CPU instruction. Technical question for you. How many CPU instructions can we do in a second today on the average processor? I got a technically correct answer at the front, a lot. I would have said lots and lots, right? So what does this allow me to do? It allows me to scan billions of rows per second per CPU core in memory. Now you might be thinking, oh, that sounds pretty fast, but you know, the buffer cache is pretty fast too. What's the difference between them? It's about 100 times faster in the column store. If I've got a single processor scanning data in the buffer cache in rows, I can do tens of millions of rows per second. Still pretty fast, but if I do it in the column store, it's billions of rows per second, okay? Now, analytic queries don't just scan and filter data. They're also going to need to do some joins, and we have optimized the joins to take advantage of this new columnar format. I'll let you in on a little secret. The column store really only does one thing well. It scans and filters data very effectively. So we've had to change the joins and aggregations to be scan and filter operations. How did we do that? We did it by taking advantage of a Bloom filter to convert a join into a scan. And we did the same thing with aggregation. So if you've got a group by in your query, we're able to effectively turn that group by from, traditionally it's the last operation in the execution plan. Now we're going to do that group by as part of the scan so that we can take advantage of what the column store is good at, which is scanning and filtering data. So if the future is this mixed environment of row and column format, one place you might want to start taking advantage of it is on a standby environment. And ideally, if you've got active data guard, it means that you have a database, a full copy of production available for read or for reporting already there. How many folks are using active data guard? Okay, several of you. And are you using it for reporting that standby that you've got? Yeah, right? So by having the in-memory column store available on the standby and allowing it to have a completely different set of data in memory on the standby versus the primary, you can effectively double your reporting workload. Because you can offload a chunk of the reports over to the standby and have them operate on a different set of data, maybe a longer or larger amount of data that you might need to look at. Maybe you're doing year-over-year analysis. All of that can now happen on the standby instead of on the primary. From the developer's point of view, as I said, you can sleep for the next 2 or 3 minutes. I'll wake you up to get you back in, because your code doesn't need to change. There's nothing you need to do to take advantage of this. It happens automatically. When your query comes in, we automatically decide to direct it to the column store. Now, but we have put in some things to improve the performance. As I said, typically we're translating joins into scan and filter operations in order to be able to speed them up in the column store. But we're only able to do that if you lovely developers put a filter predicate on the query. In other words, it says select something from a table where column equals or column between A and B, something like that. If you don't give us a filter predicate, we can't do the Bloom filter. So for the cases where you need to join two tables and you don't give me any kind of filter predicate, you just say A joins to B on column 1, then I need to do something to help improve those queries. And in 12.2, we've done that by allowing us to be able to complete the join on the compressed columnar formats. Okay, so prior to this, you would have had to read the data in the column format, decompress it, and then apply perhaps a hash function to it, and then complete the hash join. With this new functionality, what we can do is we'll ensure that the two columns that you're trying to join on, that they go in memory using the same compression algorithm so that we can actually complete the join on the compressed values and then decompress the result and return it to the end user. Now, why does that make any difference? Well, think about it. Compressed data is much smaller. That means the join will be able to stay in memory much more easily, and it will allow us to do a lot more concurrent joins or concurrent work at the same time. So how do I do that? You're going to create a join group which tells us how the tables are joined together. You only have to do this once, and then as we bring that data into memory, we'll make sure that those two columns are co-encoded, is what we call it, but basically compressed using the same algorithm, the same symbols, so that we can do the join on the compressed data. Yeah?
Can you tell that that's happening in the execution plan?
So the question is, can I tell from the execution plan if this is happening? And you can, and I should have included the slide, but it's quite delicate. It's not a new operation in the plan or a new join type that you see listed in the execution plan. You've got to be using SQL Monitor. How many folks are familiar with SQL Monitor as a tool for looking at your execution plans? Ooh, okay, not as many as I was hoping. But in SQL Monitor, what it shows you is the same standard execution plan table that we see, but it has an other column in it. And it's got a binocular that you can click on. And if you click on the binocular, it tells you that it's doing this kind of join. It is also in the XML column in the plan table. And I believe I've blogged about how you can find it, but it's also in the in-memory white paper exactly how you can find it in the execution plan table, but it's not a new operation in the execution plan itself. So a little tricky. Ideally, you should be able to tell because it's gone faster. But yeah. All right. One of the cool things that all you lovely developers want to use is JSON. How many folks are actually using JSON today in production? Okay, some of you. But one of the things we do is we don't store JSON as a new data type. There is no JSON data type in the Oracle database. It's actually stored in any kind of string type. So it can be a varchar 2, it can be a blob or a clob. If you put larger JSON documents in the Oracle database and you store them as a blob, originally if it went into memory, if you were trying to scan and filter basically by asking, you know, I'm only looking for JSON documents that are about San Antonio, Texas, then we would go through and return all of the blobs and have the SQL execution engine do that evaluation for us. Now in 12.2, we're storing JSON in a new binary format in memory, which allows us to be able to filter within the JSON documents while they're compressed and only return the JSON documents that truly have San Antonio in them. So it's a much more powerful way to use JSON because it allows you to effectively scan and filter the documents within the database rather than you having to retrieve all of them and do it in the application. So it's quite powerful. And I'll spend a little more time on JSON in the database because I really do think it's important for the developers to be aware of all of the functionality that you have there so that you don't have to reinvent the wheel yourselves in the application code. But it does make it quite exciting. Now, one of the other issues that if you are going to be placing all of this data in memory, what happens when the database shuts down? Where does the data go? Poof, it's gone, right? Well, it's not really. We were persisting all of the data on disk in what format? Row, right? It's still in the row format on disk. So that means each time the database starts up, we need to read the data in a row format, pivot it 90 degrees to create columns, compress those columns, and put them into memory. A little bit time consuming, certainly CPU consuming operation. So, excuse me, what does that mean? It means that we could effectively checkpoint the content before we shut down the database so that when we start back up, we just read the column compressed format off disk and we place it into memory. Oh my gosh, excuse me. Excuse me. So how do I do that? You create what we call a fast start tablespace. And you tell us that you're okay with us duplicating the data on disk just for these objects in this columnar compressed format. And Oracle will automatically checkpoint the contents of the column store to disk. So when the database shuts down and restarts, we can read it directly from disk into memory in the right format and not burn so much CPU doing the compression, which is a very CPU intensive operation. Don't let the name fool you. It's only fast if you have enough I/O bandwidth to sustain us being able to read the data quickly off disk. So if you're on an Exadata or you've got a nice large I/O subsystem with lots of bandwidth, you will see a tremendous performance improvement over the traditional operation. If you've got very poor I/O bandwidth, in other words, you're I/O constrained on your system, the word fast should be removed from the topic because it is not going to be fast. You're basically trading I/O for CPU. So it is a trade-off. You have to make sure you've got enough of it. All right. In case you weren't interested in memory, let's move on to other performance things that you might be interested in. How many folks have indexes in the database they run today? Okay, good. A little bit more of you are going to be a tiny bit more interested in this one. You may or may not have known, but index compression was the very first type of compression Oracle offered all the way back in 8i. But it had a bit of an Achilles heel. Index compression worked great if the leading edge of your index had many repeated values, okay? But if you ever went to DBA school, and ideally developer school too, because you guys should know what kind of indexes you need for your applications, you would have been told when you're creating good indexes, you should put the most selective columns or the columns with the most distinct values up front in the index so that we get better elimination and we read less blocks. Those two things don't really go together. I need lots of repeated values at the beginning to get good compression. Oh, I need lots of distinct values to get good selectivity from this index. Those things didn't really go together. So index compression wasn't always that helpful up until now. But I believe in 12.2 we've solved that. There is new index compression available. It uses the same algorithms we're using in memory to compress the columnar data. They're using them now for indexes. The example here, I'm not supposed to tell you who it is, and given the fact I'm being recorded, maybe I shouldn't, I just realized. It's a German company, 3 letters, write applications that run on many databases, but mostly Oracle. I think you can kind of figure out who it is. They love themselves some indexes, right? They have a lot of indexes. In fact, in this one particular system, which I think is their CRM system, they have 1.2 terabytes worth of indexes, never mind base data. So they were a smidge concerned that they weren't getting any decent compression. They motivated us to start looking at index compression. And so what we did is we introduced multiple levels of this columnar compression for indexes. With low, they got about 2x reduction, but with high compression, they got nearly 5x compression. Now, you might be saying, oh, Maria, you just told me that compressing data, it's CPU intensive, blah, blah, blah. What's going to happen to my performance if I do this? I may save disk space, but disk is cheap. What about my performance? Well, they saw about a 13% improvement in performance because when they had to read those indexes from disk, the volume of data they were reading was far less. So there is advantages to it to improve the throughput of the workload as well, because the volume of those indexes is far less. So something to think about. The other thing that Oracle has had for a long time, but let's face it, kind of sucked, was index usage tracking. Do I need this index, yes or no? How many people have had that conversation at their office? Right? Do we need this index? And of course, no one wants to say, no, we don't drop it, right? Everybody's like, I don't know. And the reason they don't want to drop it is no one wants to be the one when the quarter end or year end workload starts running and it's slow as a dog, you realize, oh, maybe we did need that index that I dropped. Maybe I'm in trouble, right? So in the past, Oracle had index tracking in the database since 10G, but it was the yes-no game show, right? Either the index was used, yes, or the index was not used, no, right? Now, what we didn't tell you was sometimes sneakily in the dark, while you're asleep, we use the indexes. You're thinking, you what now? But yes, we do. During the maintenance window, what does the Oracle database do for you by default? It gathers statistics. And what you might know is the optimizer is a sneaky individual and sometimes uses your indexes to be able to gather stats. So you wouldn't have known. So as soon as we did that, that would change the yes-no game show to yes, right? It would say, yes, this index is being used, even though it wasn't actually being used by your application at all. So now what we've done is created a new view. It's called DBA Index Usage. And what it's going to do is it's going to show you exactly how many times the index has been used and by whom. So was it the application code? Was it us sneakily doing it in the dark while you were sleeping? You'll actually know who did it and whether or not we can drop that index. So it's a much more powerful tool for you than what we previously had with just yes and no, so that you might actually be able to get rid of some of those indexes that nobody uses. All right, let's move on to security. How many folks are being hounded to make sure that the applications and the databases are more secure now than ever before? I know I am, for sure. How many folks were at the Sunday symposium, by the way, and heard my confession that I had to go to security school? Yeah. So in my previous role as a performance person, I granted everybody DBA because it was just easier, right? I mean, God, privileges, roles, what does somebody need? I didn't worry about any of those things. And I certainly wasn't going to encrypt any data for fear it might impact my performance, right? So then I got sent to security school. And now I'm reformed. And there's nothing worse than a reformed security bigot. So yes, let's talk a little bit about security. Traditionally and historically, we've done the security in the application. We've decided who gets to see what data, typically in the application code, which works great within that one application until these pesky data scientists arrived. How many folks have data scientists in their company? Where did these people come from? Right? They did not exist 5 years ago. I don't know what other name they went by or whatever, but they're the ones that I worry about most. Why? Because they never come through an application. They want direct access to the data themselves. They don't want to go through any application. They want to write their own queries, ruin the performance of our lovely database, but that's what they want to do. And if we do all of the security implications in the application, they're not obeying any of them. Why? Because they're getting directly on the box and running their queries. So we need to start putting the security in the database. You also want to start worrying about this if you are playing the cloud game. Now, I know not many of you put up your hand with that right now, but you should have an eye on that in the future, because I certainly don't want anybody else's DBA poking around in our data. And so you can take advantage of things like Data Vault to prevent DBAs from being able to see the information that's there, being able to see your customer information. You can also do redaction and data masking to hide some of that critical information from those that need to be able to do some of their magic, but not see all of the critical data, such as our lovely friends, the data scientists, right? And of course, you can do the policy managed kind of security. But even if you're not doing any of that, have a go at one thing. I want you to start thinking about encrypting your data, at least at rest. First of all, most industries are now coming out with policies and things that you've got to adhere to, guidelines or whatever that you've got to adhere to, that the data is going to have to be encrypted, at least at rest. It's effectively locking the back door, is how I was told about it in security school. You really just want to make sure if anybody's trying to sneak in and just get onto your storage and grab the data files, it means they can't see anything. So the big problem, and one of the reasons why a lot of people didn't encrypt existing databases, was because you typically had to export the data from one tablespace and import it into an encrypted tablespace in order to get this to happen. In 12.2, you can now encrypt the data online. While the queries are running, while the application is going, have the data encrypted on disk for you. Now, does the tablespace need to be big enough to hold 2 copies of the data? It does. Not quite 2 copies, but because we do it object by object, but you do need a little bit of overhead in the tablespace in order to do it. But it means it happens online. The transactions keep going. No export, import required. No downtime required. So even if you don't implement any of the other security goodies, encryption is not a licensed option. It is free. It's in standard edition. Take a look, and take a look at the online table encryption if you're moving towards 12c to be able to do it. All right, developers, little goodies for you, but as I said, a lot of you went to Chris, so this will seem a little less exciting. But the 3 biggies, I think, for developers, the first is case-insensitive search. Now, anybody who's ever put an upper function on a column in order to do a comparison, should be looking very closely at the new goodies of case-insensitive support. Because you can do it on a column. You can specify this attribute just on a single column. You can stick it on a table, or you can stick it on the entire schema if you wish. Say to Oracle, I want you to do all of these searches as if they're case-insensitive. If you're using multiple languages, and some of those languages have those funny little accents and dots and things hanging around in the language, those guys, you can also do accent-insensitive searches by taking advantage of this as well. The reason I'm pushing it so hard is that if you put an upper on a column, you completely mess up the optimizer. Right? And we should do our best to be friends with the optimizer. I know we think it's the devil incarnate, but really, it's got a very difficult job to come up with the execution plan. We should help it out. Why do I say that? Let's imagine we hired some interns for the summer, and their job is to insert data into the customer table for us. Now, the first kid always comes in super early. Bit of an idiot though, managed to turn on cap locks the day he arrived, still hasn't figured out it's on, and every time he inserts data into the database, it's all in uppercase. So he inserts the name Smith, S-M-I-T-H, it's all in uppercase. His buddy, who never's on time, doesn't understand punctuation whatsoever and inputs everything completely lowercase. He also inputs a customer with the last name Smith, but in his case, it's S-M-I-T-H, all lowercase. The third golden child arrives, always also on time, and is fully versed in punctuation and language skills, puts an uppercase S for Smith, and then lowercase S-M-I-T-H, okay? So M-I-T-H. So how many distinct values do we have in our customer column? Three, right? One uppercase, one lowercase, one mixed case. You come along and you say, select star from this table where upper last name equals Smith, S-M-I-T-H, right? How many values does the optimizer think it's going to get back?
One.
The optimizer assumes it's going to get one when really there are three. Okay, so you're messing with its mind. In fact, actually, it's not really one. The optimizer, as soon as it sees the upper, doesn't actually know what it's going to do to the number of distinct values. In this case, it turns 3 into 1, but it doesn't actually know that, and it begins to guess the cardinalities. Typically a percentage, 1% or 5% of the rows in the table. It's actually guessing. It doesn't know what it does. So by doing case-insensitive searches and getting rid of those upper functions from your code, and I'm afraid I don't have a shortcut for that. Somebody is going to have to go in there and remove them. It does actually allow us to get much better optimizer estimates for that. All right, moving on. Longer identifiers. Bring on the big names. I'm very excited about this. And in fairness, it was the optimizer developers that triggered this, like pushed it over the edge. In 11G, we introduced SQL plan management. And if you look at the names of the views that were used to, and dictionary tables that are used to manage those SQL plan management, we got very creative with the names, which makes them impossible for anybody to remember because we were trying to squeeze the name into the 32-byte limit. So now it's 128 bytes, not characters, bytes. So if you've got a multi-byte character set, it's not 128 characters, but it's certainly longer. Everything except table spaces. So your table spaces are still stuck at the shorter names. And I did ask why. I'm like, hang on a second, tables, indexes, views, materialized views, IoTs, everybody got a longer name. What is wrong with table spaces? And apparently it is something to do with the data file numbering and how we turn table space names into numbers or something whack in the database is the excuse for it. But it is a limitation. They are not longer, but everything else is. If you're worried to find out if the object you want to have a long name has it or not, look at the dictionary views for them. So user underscore tables, look at table name. It'll show you that now it's 128 bytes. Or look for IoT or materialized view, you'll see the same thing. Look in table space and you'll see the shorter name. So if you're worried whether or not the object you're trying to have a super long descriptive name can tolerate it or not, you can look in the data dictionary. Yes, sir?
Why didn't they just go ahead and make it bigger than
Oh, the question is, why did you stop at 128? I'm assuming that there's some internal variable we're using in the code, and they just upped it to be 128 bytes would be my guess. But it's a lot. I mean, you can kind of get, you don't think it's a lot?
You need 4,000.
Are you writing an essay? This is my... Can you imagine the developers trying to type that name in every query? I mean, these are the folks that call every table T, man, right? I mean...
Stuff and convert it to names and so forth, and you're going to get huge names. I get it all the time.
They want... How big do they want it? What are they saying? This is the first table I've ever created. It's the most exciting moment of my life. I mean, you can probably get that into 128 characters, right? Okay, well, I will bring it back that you're looking for longer, but I think 128 is pretty awesome in comparison to the 30 that we used to have. But okay, I'll take it back as a requirement, 4,000 characters. All right, globalization, or better default language. Whether we like it or not, we are all turning into global companies. And so we will have lots of interesting languages and character sets in there. So if you create a brand new database in 12, what you're going to get is UTF-8. And I do see us moving more towards this as we become more global companies. And it's using Unicode 7 support automatically out of the box. Now, if you upgrade, we're not going to magically change the character set on you. But for any new database that you create, that is what you're going to get. Now, JSON, let's talk a little bit about that, because I feel bad that I tend to always talk to the DBAs in the room and not to you lovely developers. So let's have a little kumbaya moment, and we'll talk a little bit about what you might be more interested in, which is JSON. And I get it. I really get why folks are interested in this. It does speed up the implementation of a project to not have to sit for hours and draw out what the schema might look like and try and think about every column you might need. And one of the things we tend to do in that process, at least historically, was we'd put in a bunch of empty bloody columns. This would drive me bananas, right? That'd be called, you know, column 1, column 2, column 3, spares, just in case we might need something in those. With JSON, we don't have to do that, right? We can change the format of the JSON document from document to document, adding new columns if we need them, without it impacting anything, because no new columns have to be added to the table. Nothing changes. Which is great for you guys in development land, not so great for those of us who only speak SQL. I know it's shocking, Jeff, but I didn't think it was that bad. But yes, don't worry. If you only speak SQL like me, you can still navigate through a JSON document using dot notation. So if you're not familiar with this, we typically, when we're writing SQL, we can say the table alias. So in this case, my example is C. Then we can say dot column name, and then we can actually go through the JSON fields and use the dot notation to walk through a JSON document. What does that help me do? It allows me to join JSON documents to relational tables, because one of the JSON fields matches a column in the other table. It allows me to select out only individual pieces of the JSON document. So for example here, I've got a table. It's only got 3 columns. Most of the information is in something called booking details. I'm recording movies and what time they're on, what theater they're showing in. If I just want to know what movies are currently playing, I can select from the movies, that's my table alias, the column name, booking details, .movie will give me a list of all of the movies that are in the JSON documents in my database. Quite powerful stuff. And as I said, it can be used not just in the select list, but in the where clause predicate using joins, and I can even aggregate over it. So very, very cool stuff. And there's a bunch of other things. One of the other things that made me extremely nervous when I heard about JSON in the beginning, and the fact that everybody wanted to use it, was who knows what's in there? Like, you've been inserting JSON documents for quite some time. What's in all of them? I don't know, right? So they introduced this thing called a data guide. And what it does is you run a PL SQL package called dbms JSON. And what it's going to do is it will output all of the JSON fields, what data types they are, how long they are, that are in those JSON documents. And if you really want to make it Sesame Street easy for the SQL folks in the world, you can actually have Oracle automatically create virtual columns for each of the JSON fields so that they appear as a legit column in the table. Now, why would you do that? Because some of us idiots really just don't want to navigate JSON. We only want to describe tables, see all the columns, and then work out our queries. The only gotcha with this is that the columns end up with funky names. What do I mean by that? The column, these virtual columns, they'll have the JSON column name, so booking details, $, and then the field, the JSON field name. Now, why? Because that was my first question. I'm like, the state of that. Why didn't you just call it time, right? And the JSON developers had a good reason for it. They said to me, what if you had 2 JSON columns in that table? What if both of them had time as in their JSON documents as a JSON field? How do you know which time is which? And I'm like, oh, God dang it. Okay, fine. Let's call them stupid names. So the good news is you can do it this way and have us automatically append. If you know there is only going to be one JSON column in your table and you want to give it a cleaner name, you can just do a standard add virtual column, right? You can do a standard add virtual column or either as an alter table or as part of the table create, and we'll automatically generate it for you as the queries come in. Yes, Jeff?
Can you rename the generated columns?
I have not. So the question is, can I rename those lovely automatically generated virtual column names? I don't believe you can, but I haven't tried. So if you're fussy about the names of your columns, then you can do it with by doing just manually adding the virtual columns. There is a ton of other super good enhancements that I know Chris Saxon covered yesterday, so I'm not going to bore you with repeating it. If you didn't attend Chris's session yesterday evening, if you were too excited to just get out there into the rain, I understand that. All the sessions have been recorded, and so you can just listen to the recording of that if you're interested in any of these great things. And Bryn, I'm sure you're doing some PL SQL.
I was going to say, in summary, PL SQL mostly harmless.
Oh, there you go. PL SQL improvements, mostly harmless. You heard it here first, folks, directly from Bryn. But no, some very cool stuff. If you're interested in playing around with a lot of that cool stuff, there's free tutorials already available for you on something called Live SQL, which is a website that is actually an Oracle 12.2 database behind it. It's got a huge repository of tutorials and example code up there, but you can also create an account and store your own examples there. So if your DBA is a bit mean with the databases, and they won't give you a new 12.2 database because they're meanies, then you can actually start playing around with all of this new technology and the functionalities that we're talking about by going to Live SQL and creating yourself a little account. That way you can store all of your scripts right there. And if you should have an issue with something you find and you'd like to ask Tom, then what you can do is you can just send us a link to your Live SQL to show us that. So that's kind of cool. All right, moving on, trying to get back on track to this whole futures thing. And one of the things I want to talk about is manageability. And the new direction for the Oracle database, whether we like it or not, is towards multi-tenant. Now, before you freak out and say, I'm not adopting that, you want money for that, one pluggable database in a container is free. So even if you never want to buy the option, you never want to do multiple, just think about moving towards that architecture, and I'll explain why that might be a good idea in just a second. Now, if everything I've just said sounded like a foreign language, bear with me. Let me go over what this is all about. In 12, rather than having an individual database for every application, which can be quite resource intensive from a hardware perspective, because each one of these is going to have its own memory allocation, its own set of background worker processes. What they're looking to move us all to is that we would create one container database that has an SGA and all of that, and one set of background worker processes, and these application databases become PDBs, or pluggable databases within that container. Now, don't freak out. They are all seen as separate databases. So just because somebody can connect to the general ledger doesn't mean they get to see the other applications in that CDB or their schemas. It can all be done, or they are all independent, but they are sharing a set of background worker processes and memory. You can control exactly how much CPU, I/O, and memory each of them gets using Resource Manager. So you can keep them all completely separate, no noisy neighbors scenario, ideally, with this. So what's the goodness about this? Why would I care? Because after all, I said they're going to charge you money for it. There's a couple of really nice advantages of it. The first one comes when you've got to spin up dev and test environments. One of the quickest ways to do that is to clone the production database. And with a PDB, you can clone an individual PDB and then create snap clones from that. Now, what's a snap clone? If you're not familiar with the terminology, it's basically a copy of the database, but it's only written on change. So if you never change it, it doesn't require any additional storage, which is all well and good. We can create our snap clone from production. That can happen online, by the way, so no downtime required for that. We take a copy of it, we put it in a new container, and then you can create these snap clones for everybody in development. Problem with that, though, tends to be that as time moves on, there's a difference between the production database and our clone. So we want to be able to make those changes, and with multi-tenant you can. We just ship the changes to your clone, we'll allow it to refresh, and then we can snap new clones out for everybody. So we could do this on a nightly basis so that everybody in dev test may have the latest and greatest version of the data so that they can be going forward with it. Quite powerful stuff, all done on a PDB basis. This is the one, though, that I think even if you've got just one PDB and a CDB that you might want to consider, which is PDB Relocate with no downtime. While the application users are on, I can shift a PDB from one container to another. Why would I want to do that? Maybe I want to apply a patch. Maybe I want to do a small upgrade. But what it's going to do is, as the connections are coming in, we take a copy of the database, we move it to the new location, and then we redirect the application to use that new location. And we actually leave a little tombstone here. So if somebody is connecting and they've got information about the box and everything, they're not doing it correctly through a service. But if they are those pesky data scientists connecting directly, when they get here and they try and connect, we'll automatically redirect it to the new location. Now, it will require an extra network hop for their connection, but they will get there and they won't get an error, which is quite useful. So, something to think about. All right, how am I doing for time? At some point, you might need to drag me off with a hook. Okay, no, we're good, 9:15. So, availability is the next big thing that I want to talk about. And for the developers, normally you get to tune out at this point because, like, that's not my problem. However, this one you might want to stay tuned in because we're going to talk about sharding. Now, sharding is brand new with Oracle, and I do think for a certain number of applications, this is going to become the future. For most applications that need to scale, you can do that scaling with either Rack or DataGuard. You can kind of get the scale and availability without too much drama for about 90% of the applications that are out there. But there is about 1% of applications that truly need global scale OLTP. And especially if you're dealing with some folks that in your company that might reside in places like Europe, where they've got all these regulations that our data can't leave our land and blah, blah, blah. If you're not dealing with that, be grateful. But if you are dealing with it, it does mean it's going to make it very difficult to get a global view of what's going on. So how does sharding fix that? Sharding allows you to take a very large database and break it up into physically different, smaller databases that are seen logically as one database to Oracle. Why would you want to do that? By having them as on physically separate servers, physically separate databases, they can be in physically different countries, okay? If one country, you know, like the French always go on holidays for a month in August, right? So if they disappear and nobody realizes that their server is down, doesn't matter. Why? Because it's only the people who are interested in the data, in the French data, that are going to be affected. The rest of us all operate on independent hardware, so just because they're down doesn't mean the rest of us can't access our data. So it's quite powerful in that case. And it does, with Oracle sharding, you have the ability to run a query across all of the shards and get a result. However, because they are physically separate databases, don't expect that query to fly like the wind, right? So it's only useful for applications where I would say 99.9% of the queries can be satisfied within a single shard. And it's only the management guys that want to see the total picture. So how do I do that? I create tables that are sharded tables. So create table sharded, and then I need to give it a partitioning strategy. That's going to decide how the data is distributed across the shards. Similar partitioning to what you get at a table level, but there is a new type here called consistent hash. So this is the one that we're going to use to try and get an even distribution of data across all of the shards by hashing on the sharding key. So in my case, that's the customer ID. The reason why it's not just hash and it's consistent hash is that the whole goal of sharding is that I can scale infinitely. And if I add a new shard, we should be able to quickly redistribute the data to get an even amount of data on all of the shards, even though we have one more. Okay? Consistent hash allows us to do that. It allows us to do the minimum amount of data movement to have an even amount of data across all of the shards. Who's using ASM in their databases? Anybody using ASM? You know, if you lose a disk or you add a disk, we rebalance. It's effectively the same thing here. It gives us a cleaner way to rebalance the data. All right, so how does this whole thing work?
Quick question here.
Catch me later. All right, so just so that everybody stays on the train and then we can go over. So at this point you're thinking, yeah, we're just going to turn all of these rack databases into shards. It's going to be awesome. Minor problem. All of your applications may need to change. Why? Because the application does need to be aware of sharding and it does not need to be aware of rack, because rack is a single database, right? These are not single databases. In order to get this to work and perform, each query must supply the shard key so that we know which shard to send it to. Otherwise, every query that doesn't have the shard key becomes a global query and must be executed across all of the shards. And what did I tell you that was going to be? Slow. So here's how it works. You send us a query that's got the shard key. Let's say, for example, it says the customer ID is 123. The application server is actually given a directory that says where the shard keys are on the individual shards. It says, oh, I see you. You're going to execute over here on shard number 1. If you don't give me the customer and the query comes in without any customer ID, you go over here to the lovely coordinator database. He divvies out that query to absolutely everybody and then sits there patiently. You know, it's a bit like... what's that time, the game show where it goes doom, 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 Jeopardy or whatever, right? Yeah, right? While they're all waiting for things to happen, he sits over there waiting. Everybody executes the query, even though they may have no data for it, sends the results back to the coordinator who aggregates them up, sends them back to the application. So that's where the slow comes from. So you've got to make sure your application includes the shard key in every query. So this isn't something that we can easily translate every application to, but for the applications that need this kind of performance, actually quite cool. It is supported using all of the new cool whiz-bang bits and pieces, .NET, OP, whatever you want to do yourself. The one thing you might want to do also is replicate some of the tables. So it's easy enough for our customer table and our sales table to be partitioned on customer ID, not so easy for our products table. So you do have the ability to duplicate tables across shards if you wish. So you can do that too in order to be able to have that same table across all of the shards. Be a little careful about doing duplicate though, because when you come to changing that table, there's a lot of work in order to keep all of the shards in sync. So we're not expecting all tables that way, typically just things like product and the smaller, slowly changing dimensions. All right, let's talk a little bit about big data. Like it or not, we probably have a chunk of this stuff hanging around in our environment. How many people have a Hadoop or big data project in their world? Okay, about half of you. They're common whether we like it or not, and it is certainly, for certain workloads, a better place to put that data. I typically like to think kind of low... data that's not very valuable, if you know what I mean. There's tons of it, but it may not be very valuable, social media, all that kind of stuff. Doing that out on Hadoop, analyzing it, and maybe putting the few nuggets you've got into the database, or maybe not. Maybe you just want to join the results from the Hadoop environment with the database. Well, you can do that now by taking advantage of something called Big Data SQL. The ability to have data either in Hadoop, Oracle database, or even a NoSQL database, and run one query to touch all of them, all of those sources. So pretty cool stuff. If you are going to be doing this MapReduce stuff over on your Hadoop environment and you're too lazy or it's not valuable enough to put it into the database afterwards, you can create external tables that are partitioned that allow you to access data, different Hive partitions out in your Hadoop environment via an external table. So we can write plain old SQL against this, join it to tables within the database, and be able to quickly change out the information in those partitions of the external table from the Hadoop environment. So quite cool performance stuff. That was my 5-minute timer, so I'm just going to start speaking really fast so we get through the rest of the slides. Analytics. How many folks have ever used OLAP or anything like that? Cubes, Essbase, anything like that in the past? If you've ever looked at those in the past, you might want to take a quick look at analytic views. Analytic views don't build any additional objects in the database. They're defined on top of existing tables. But they allow us to write much simpler, cleaner SQL, similar to what you would write against a cube. So if you've got OLAP cubes today, and they work great from a query perspective, but they suck because it takes way too long to rebuild the cube every time the data changes, you might want to take a look at analytic views. Although you still need one smart person to define the view, the rest of us dummies can then write very simple queries because there's no joins required in the SQL. There's no group bys required in the SQL. So it allows us to write much simpler SQL if you use analytic views. If it's something you're interested in, drop me a note. I can bore you to death with white papers and presentations on it. It is quite powerful stuff, very cool. Last thing I want to talk about, and hopefully Chris also covered this, is the approximate functions that have been added to the Oracle database. This is cool stuff. Because one of the biggest things when we're doing things like a count distinct, that we burn a lot of performance. Let me show you an example. So here's an example where I am doing a select count distinct from a single table. And it required 8 gigs of memory and 164 gigs of temp in order to do that count distinct. So it's a large table, but I'm doing a count distinct on a single column. If I use the approximate count distinct, it's 50 times faster for a start. I used 15% less memory, and I used no temp, therefore no I/O whatsoever to execute the query. So why would I use an approximate count distinct versus a count distinct? How many people came to our website today? How many people bought beer and diapers together? How many of our customers live in California? Approximate is good enough. Now, how approximate is it? It's typically got less than 1% error rate. So it's actually very close. Not close enough to do your financial reporting on. Let me just say that, right? So yeah, no financial reporting with this one. But a ton of the queries that we do don't need to be that. And it actually, in financials, where they're starting to look at it is, my sister's an accountant, and she, at the end of every month and stuff, they're always doing these kind of fake closes on the book to try and get a sense on where they are. How much money are we really going to make this year? If your application has that ability to kind of do a fake close to just get a sense of what's going on, you could use the approximates there just to make it super fast and kind of take the heat off the system. Not in the official one that you send to the taxman and everybody else. Not in that one, but in maybe the approximate ones you might be able to do it. But for a lot of the queries that we run just to get a sense of where we are in the business, we can use these approximates. They are much more efficient. Now, before you panic and think, oh my God, we've got 10,000 lines of code, there is no way anybody's going back in there to get rid of all the count distincts, you can set a parameter to switch the existing count distincts to be approximate count distincts automatically for you. We will do the translation. Don't turn it on at the database level. If you're going to do the financial reporting on that same database, Rob, yeah, you don't want to be switching on at the database level. But maybe Rob does. But you could do it at a session level or through a logon trigger. You could mess with your lovely wife, the accountant, if you wish that way, but I wouldn't do it. You can also do these approximates, by the way, in materialized views as well. Okay, and we have lovely graph properties, but I am unfortunately out of time. So property graphs are there, and all the graphing stuff in Oracle is pretty awesome, actually. But I have run completely out of time. I want to say thank you very much. There is tons of additional resources at the back. Please fill out your surveys. Thank you.